Hello and welcome, dear friends. In this video we are going to talk about methods in C#. We'll talk more about the parameters. In particular, we'll talk about the keywords that are used when passing an argument to a method. At the end of the video, we'll find out what messages we get in the console by running this code. It is more about C# than Unity, but let's talk about parameters using objects in Unity. If you find something useful in this video, please don't forget to subscribe to my channel. This will inspire me to add more interesting content. There is a turn-based game development tutorial on Udemy. The discount coupon is in the description for this video. We're getting started. As usual, I have created a very simple scene. Alright, let's see what we've got here. The background image stores the background sprites and has the background scripts on it. I'm going to use the background scripts when we discuss the ref keywords. The girlfriend object does a lot of useful things. In addition to the image component, this object has the girlfriend script on it. And the object called boyfriend has the boy script and image components on it. It also has the sprite attached to the field called angry. That's all. Let's open the girlfriend script and start talking about methods. A variable is just a container to hold data. It does nothing else. As in life, so in coding, we need somebody or something to perform certain actions. And this guy is a method. A method is defined as a set of instructions, but let's just say that a method is basically just a little block of code where we can perform a specific task. The task is enclosed in these curly braces, unless of course we write everything correctly. In most cases, the syntax for defining a method in C# looks like this. It has an access modifier. We have talked about access modifiers in the previous video. In our case, it is private. A method also has the return type. It is void so far, and we're gonna talk about return type a bit later. A method's name is a unique identifier. In our case, the girl wants to count the money she has. The name of the method has to be unique, but there is one tiny detail that we'll also talk about. We can add parameters to pass and receive data from a method. In the first example, we don't use parameters, but we'll add them in the following examples. And the last part of the method syntax is the method body. This part is executed when a program calls a method. If a program doesn't call a method, then this method will be useless. What does the countMoney method do? I have declared two private variables of integer type. The girlfriend has some money in her account and some cash. The method performs a simple task. It calculates the amount of money the girlfriend has and tries to print the total amount of money. Very simple, but it will not work if I do not call these methods. I can check if there is a reference to the methods. If I hover my mouse over three dots icon, then C# tells me that this class member is not used anywhere. I can check references in another way, right-click on the methods, and I can select the Find All References methods. In a new window, I will see all the references to the methods. Well, at this moment I have no references. Let me fix this and call the methods inside the start function. Now, if I hit the play button, I will see the message. It is good, but what if I want to use the result of calculations outside the methods? The total amount is the local variable and I cannot access it outside the methods. How can I get this value? Well, I can initialize the class scoped variable. The method modifies its value, so I can use this value somewhere else. This will work, but in this case I have to worry about the execution order. I must always be sure that the methods will be called before I will use the variable modified by the methods. If there are thousands of such variables and methods, then I may go crazy. There is a more efficient way. To get the value of the variable, I can change the method's return type. Now it is void, it returns nothing. I want to get the value of the total amount variable of integer type, so I can replace the void keywords with the integer type and add another keyword, which is the return keywords. It is important. If I have replaced the void keyword, I have to add the return keyword and the variable whose value I'm going to get. The type of the variable must match the return type. I want to get the value of integer variable, so the method has to return the integer variable. If I add the variable of another type, for example of string type, C# throws an error saying that it cannot implicitly convert type string to an integer. Well, some types can be implicitly converted to another type. For example, the return type can be the float type. In this case, C# implicitly converts the integer to float. But these are kind of special cases. It is not the right time to focus on this topic. Okay, the method returns the integer value. Now I can use this result. Let me activate one more line. I have declared the variable of integer type, and I have assigned the result returned by the method to this variable. Obviously, the variable must be of the same type as the method's return type. Now I can use this value outside the count money methods, and in this case I do not worry about the execution order. I don't care if the method is called before I refer to this variable. For example, I can print this value, no problem. I can modify the body of the method a bit. I don't have to declare the local variable at all, and I can replace the variable with the sum of two class-scoped variables. C# will not throw an error. You can return the value of variables of any type. It can be a value type or reference type variable. For example, a variable can be of image type or boy type. Just make sure that the return type matches the variable type. And that's pretty much it. Let me clean up the script a bit. Okay, I have initialized the variable of integer type. It is the cost of the handbag. This is an expensive handbag, but the girlfriend wants to buy it. She needs to find the money somewhere, and she asks her boyfriend for help. There is a field of boy type, and I have used the findObjectOfType method to assign the object to it. This is one of the methods created by the Unity developers, so we can use it since it has an appropriate access modifier and syntax. The method returns the object of specified type. The getSomeMoney method is called inside the start method. The method prints only one message so far, and it calls the solveMoneyProblems method, which is the member of the boy class. Let's go to its implementation, right-click on the methods, and call the goToImplementation methods. Okay, Visual Studio has opened the boy class, where the method is implemented. The boy class doesn't do anything complicated. It has one field of sprite type called angry. I have declared the image field to get access to the image components. The sprite property is the property of the image components, so to assign the image object to the face field, I have called another method. It is getComponents method. This method returns the component of a specified type. In our case, it is the image component attached to the boyfriend object. This is a tricky method, and we'll talk about it in detail in one of the next lectures. Now it is important to check if everything is working properly. So, the solveMoneyProblems method prints a wise message and replaces the sprite. Open Unity, make sure that the angry sprite is attached to the fields, and hit the play button. Good, I see the message, and the method has replaced the sprite. Back to the boy scripts. Let's imagine that the boy doesn't want to be so rude. Let him be naive and young to buy the handbag. But the problem is that he doesn't know how much the handbag costs, and he needs this data to make a decision. The boy class hasn't got the variable that stores the value of the handbag. The first way to solve this problem is to get access to the cost of the handbag variable. Declare a variable of the girlfriend type, assign an object to the variable, and I need to make the cost of the handbag variable public. Back to the boy class. Now the boy class has access to the variable and it can use its value so that the boy can make a decision. Let me add one more variable of integer type, call it savings. Let's say the boy is very rich and let me activate the if statement. So if the required amount is less than money the boy has, then the method prints another message and it doesn't replace the sprite. Well, sometimes boys behave very stupidly. Anyway, let's check it out. Click on the play button. Okay, it works fine. Back to the scripts. To make it work, I had to make one of the fields public and I had to do extra work trying to find object of type girlfriends. It is not a problem at all, but there is another way to transfer the data. Parameters basically help to transfer data from one method to another. Let me remove the lines I have just added. I will add only one parameter of integer type, call it required amount. This allows me to use the value of the required amount variable inside the methods. C# doesn't throw an error because now it defines the parameter as a local variable that can be used inside the methods. It is important to specify the type of the parameter since local variables also must be declared correctly. At this moment the parameter has no value. I have to pass a value to it. Back to the girlfriend class. Let me modify it a bit. I need to pass an integer value to the solve money problems method. I can add 1000 and this will work. But we have a variable that stores the necessary value, so I will add the cost of the handbag variable. Now we will get the same result as in the previous example, but in this case things do not look so messy. We can add any number of parameters to the methods, but too many parameters make the code less readable. I try not to use more than 3 parameters. 1 or 2 parameters are very easy to read. The important thing here is that the number of parameters must be equal to the number of arguments we pass to the methods, as well as types. Types of parameters and arguments must match each other. If I add one more parameter, C# will throw an error. Let me open the girlfriend class. C# says that I need to add one more argument for the parameter I have just added. But there is one exception. Back to the boy class. I can add the parameter that has a default value. Let it be of Boolean type and its default value will be false. These kinds of parameters are called optional. When we call the solve money problems methods, we can ignore the optional parameter. C# will not throw an error. And I can pass the optional argument to the methods. For example, I can add true value after a comma. Okay, why do we need optional parameters? Let's imagine I have another class that also calls the solve money problems methods. The class name is creditor. I do believe that the creditor shouldn't know anything about the keys parameter. He just wants his money back. In this case, when calling the methods, we can specify only one parameter that will be equal to the amount of debt, and everything will work fine. Optional parameters come in handy when the class has no access to the value of one of the arguments, or logically it shouldn't care about its value. Okay, let's try to use the value of the optional parameter. I have added 2 conditional statements just to simplify the example. So, if the required amount is greater than the value of the savings variable, and if there is no keys argument passed to the method or the keys boolean is equal to false, the boy tries to be wise and refuses to buy a new handbag. In this case, I am changing the sprite of the image component. If the value of the kiss parameter is true, the boy doesn't care about the money and becomes very happy. As I have mentioned before, in some cases boys behave illogically. Let me change the value of the savings variable. Let it be more realistic so that the required amount is greater than the savings. Open Unity, let's see how it goes when we haven't added an optional argument. Its default value is false, so the boy becomes angry. If I add the true value to the method, then I will get another message. There is one more issue that is worth mentioning. If I copy the method, C# throws an error, saying that the method already exists. As I have mentioned before, the name of the method has to be unique. However, if I add one more parameter to the method, C# defines this method as a new member of the class. The two methods differ only in parameters, but these are completely two different methods. It's good practice when methods with the same name perform similar tasks, but this is optional. You can add to the body of the method whatever you want, just don't forget to pass correct arguments to the method to make sure that you call the right methods. Okay, let me clean up the scripts to go to the next part of this video. Let me reassign the value of the parameter. When the method is called, the required amount variable becomes equal to 400. Okay, let's proceed with the girlfriend class. Let me print the value of the cost of the handbag variable twice, before and after I call the solve money problems method. If I hit the play button, I will see that the method doesn't change the value of the cost of the handbag variable, and it shouldn't. The method changes the value passed to it, but it doesn't change the declared variable itself. This happens because we have passed a value to the method, not a reference. The parameter in this case just takes on a new value and the method continues to work with this value, and it is okay. A parameter is just a local variable that only exists within the scope of the method. Those variables are initialized when you call a method by the values that are passed in. What if I want to modify the value of the cost of the handbag variable for whatever reason? For example, the boy will buy the handbag of lower quality, or he will buy a bag on Black Friday. Let me open the boy script. What can I do? I can create the reference to the girlfriend class and reassign the value of the cost of the handbag variable, if the variable has the appropriate access modifier. And if I want to get access to the instance of the girlfriend class placed in the scene, I need to find this instance calling findObjectOfType methods. This will solve the problem, but again we have done the extra work. C# offers another solution. It allows passing an argument by reference, not by value. Let me remove the reference to the girlfriend class. To pass a reference, I need to add the ref keyword. I have to do it twice, the first time for the parameter, the second time for the argument. Open the girlfriend script. Okay, now I'm ready to click on the play button. The value of the variable became equal to 400. Good. This happens because using the ref keyword, I have passed the reference to the variable, not a value. The parameter here is not a local variable anymore, it is a reference to a regional variable. When I try to change the parameter, I change the original game object. I hope it's clear. Well, what is about the reference type variables? Does it make sense to add the ref keyword to reference type variables? I will show two examples to answer this question. If you don't remember the difference between the reference and value type variables, please find the video called Variables. Let me get access to the image component of the girlfriend object. To do this, I have declared a public variable of image type and I have called the getComponent method to assign the object to this variable. Make sure that you have added Unity Engine UI namespace. Okay, let me pass the girl's image argument to the method. open the boy class and change the type of the parameter. Referring to the parameter, I can change the color of the object. If I press the play button, the girl becomes red. I guess she's angry a bit. Well, in this particular case, we don't need to use the ref keyword at all. If I remove the ref keyword, I will get the same result. That is actually why we ignore the ref keyword in most of the cases when we pass the reference type variable to the method. We usually get the same result, however, there is a difference. Let me show it. To make it clear, let's proceed with this example. If I don't use the ref keyword, C# creates a copy of the reference to the original game object. And when I change the parameter value, the original object is changed. That's why the color of the girlfriend object has changed. If I use the ref keywords, I get the same result, but for a different reason. In this case, C# creates a reference to a reference. When I change the parameter, C# refers to the reference to the original game object, and the girlfriend object becomes red as well. To understand this better, let me add some lines. It is time to use the background object. I already have the reference to the girlfriend object. Good. I have added the background variable and I have assigned the background object to the variable calling the findObjectOfType method. Now let me reassign the original image object. Let's say it is not a component of the girlfriend object. It is a component of the background object. I'm referring to the original object stored by the girl's image variable, which is the member of the girlfriend class. And I have added the reference to the image component of the background object. Having reassigned the original object, C# will set the red color to the passed image variable. Let's see what happens when I do not add the ref keyword. Open Unity, click on the play button. Okay, we get the same result. Now let me add the ref keyword for the arguments and the parameter. Let's see what will happen. Click on the play button, and in this case the color of the background object has changed. It is interesting, isn't it? Let's see why this happens. If I remove the ref keyword, C# copies the reference to the original game object. If C# reassigns the original game object, this game object doesn't affect the copy of the reference stored in the parameter. The copy of the reference still refers to the image component of the girlfriend object. When I use the ref keyword, C# creates the reference to the reference. When I reassign the original reference, the copy continues referring to the same reference and, as a result, refers to the background object. In this case, there is no connection to the girlfriend object anymore. That's why we got another result. This kind of situation doesn't happen often, but let me give you an example of a case that may happen in practice. Let me open the background script. Let me activate the disabled lines. Okay, I have declared the variable of the string type. String type is the reference type variable. I have also created two methods. One of them has the parameter of string type. The other one also has a parameter of string type. But in the second case, I have added the ref keyword. Both methods try to reassign the value to the parameter. Very simple. I am printing the values of the string variable inside the start method. I will do it 3 times before and after calling the methods. Let's see what we can get. If I hit the play button, I will see 3 messages. Note that after calling the first method, the value of the variable hasn't changed. The second method changes the value of the variable. So why is this happening? When the first method is executed, C# creates a copy of the reference to the same message. When the method modifies the parameter, it modifies the reference so that the parameter refers to another object of string type. Every change to a string creates a new string. The method doesn't modify the original reference, and as a result it doesn't change the value of the class scoped variable. In this case we have two different objects. When the second method is called, C# doesn't create a copy of a reference. The method creates a reference to a reference. As a result, the parameter refers to the original object. And when C# modifies this reference, it changes the value of the original object. That's why we get another message. I hope this example gives more understanding of ref keywords. There are other keywords with which we can pass arguments. These are out and in keywords. Don't be afraid, I'm not going to go deep into this topic, I just want to give a couple of examples and show the main difference between these keywords. The ref keyword states that the parameter passed may be modified by the methods. We have done this in the modify reference methods. The in keyword states that the parameter passed cannot be modified by the methods. The in keyword makes the parameter read-only. If I replace the ref keyword with the in keyword, C# throws an error. Out keyword states that the parameter passed must be modified by the methods. Let me replace the in keyword with the out keyword. It works fine, but if I remove the only line in the method, C# throws an error saying that we must reassign the message parameter. In this case, a parameter has to be initialized within the calling method before we use the parameter. If I try to use it before initializing it, C# throws an error. Okay, I hope you found something useful in this video. Thanks for watching and see you in the upcoming video.